Hello, I'm Muto. There are many different topics on the internet, and one of the more popular is AI, artificial intelligence. There are many speculations about that. Some are more true, some are less true, and still I think that it is my obligation to share my own thoughts about what it is not, and what will be in future with that. Why should you listen and better not listen to me? Because I have the bachelor degree in system analysis, system engineering, and one of the more hard emphasis we had was on neural networks, on artificial intelligence, if you may. So I may or may not have more expertise in this topic than you do, so you should or should not listen to me. Today you have to be prepared to give most of your attention on me, because what I will tell you will be very dense, and I will tell a lot of different information and a big structural thought about what is AI in general, for you not only to hear the headlines, but also for you to have your own view of what will happen and what is happening already. In order not to interrupt my meditation during the main part of this video, I will ask you right now to like this video and to subscribe. And also in the end, I will ask you to write a comment, because the comment near to the end of the video will be more thoughtful than at the beginning. I want you to think deeper, so please do it and enjoy. It is always good to start at the beginning. That is why I will start with the basics, with the overall structure of neural networks. Neural networks, AI. I will use these terms interchangeably. So what are neural networks? It is basically the mathematical structure of neuron of your brain. How it just happened. Back in the 60s, some very smart guys decided to make a computer model of a neuron in order to simulate some part of functionality of the brain. And with this idea, those smart guys created the artificial neuron, the neuron of the computer, the neuron of the neural network. Visually, it consists only of two parts, of the nodes and of the connections, the relations between those nodes. Those nodes can be in two different stages. It can either be excited or passive. In other words, either 1 or 0, just like in the computer. Between adjacent nodes, there are connections with different weights. They tell us the story about how strong one node influences the other node. So if one node is excited, which part of this information will come to the next node? Again, on the very high level, there is a certain threshold of these weights and these excited and non-excited nodes, which will either excite or not excite the adjacent node. As you can see, they are all interconnected, so every information that is put inside is used to give some result. And with that, we can see the chain of event. We have some input, we have some weights that are working inside. The nodes are either excited or not excited, and in the end we get some results. Results may take different shapes and forms. One of the more popular smaller models are that recognize the written by hand numbers and then they give the result what number it is, what number this machine thinks it is. So with just this example, we can figure out that this mostly is a classification machine. It is very good at classification because it is built on our brain. It is a model of our brain, of our neural networks that are really good at, well, classification. You may question now, how exactly does it work? I will tell you, no one really knows. It is always a black box. The relations inside don't really give any useful information visually to us. It is mostly noise, but the machine, it recognizes this information as something useful. Nevertheless, I can give you the broad mechanism that explains how this mechanism works on the high level. It is based on the cybernetic field of feedback loop. A feedback loop is broadly a process which uses the output to change the process itself in order to give the better output. How this process might look like at the basic level of neural networks. I will use my previous example. Firstly, some defined set of images and adjacent numbers is given to the machine. It reads it and makes some tweaks to the inside weights. Then this machine is given step by step new images and it tries to identify the number that is written on this image. If it is true, the machine is given the signal that it is true, and with this signal the weights inside the machine are adjusted. If the answer is wrong, it is also given as a signal to the machine, so the weights are adjusted. After some time of training, we get the machine that reliably get often enough the results that are true, and this machine can be deployed. After the deployment, this process of adjusting can and will be continued, so the machine might make itself better indefinitely. But let me be honest with you, when you're talking about AI, you're not talking about the basic level neural networks. You talk about the large language models such as Grok AI, ChatGPT, Gemini, Perplexity, and so on. So let's talk about large language model, how they are different from the basic models and how are they not different. On the very high level, LLMs are still nodes and weights between those nodes. The main difference is the amount of information that is used and the way those weights are adjusted after answers and after feedback. It is no secret that LLMs work primarily with texts, and you are more interested, I guess, in finding out how it generates the answers that look coherent and that are mostly true. Truth be told, generative AI is better explained as prediction AI because it was trained as a prediction machine. For example, some text is given to it with one word missing, and the goal of this AI was to find which word passes the best. That is how they were told, just to predict which word passes to the missing place. With such training, it generates the answers to the user input in the same way as it was trained, word by word, till the very end. And that is primarily the way how they still work. Some of the more interesting engineering part of AI is the usage of tensors. Tensors are an element of weight adjustment that uses the relation between, let's say, words in the given input to better understand what the user is talking about. For example, in English language, there is a word it. Without context, neither you nor the machine can't tell what it is. So tensors let the machine have some context. It is built in a way as a relative relation between the words in one given sentence. Of course, by today, the bigger models use complexer architecture in order to give more coherent answer to complexer questions. But the high level of how large language models work is this. So artificial intelligence is a model, it is a machine, an instrument. And as every instrument, it has limits, the boundaries of possibility, what it can and can't do. I will give you just one example of an inherent problem that even conceptually cannot be solved. It is the problem of information. Neural networks are inherently based on information, which means they do not know what they do not know. Only the information that is given to them is the information they have. They don't know anything more than what is given to them. They cannot generate anything that is inherently new. They can combine and tweak the existing parts, but not something they have never imagined. The example of such a problem was given by one YouTuber. He asked ChatGPT to generate a photo of a glass of wine that is completely full, and ChatGPT couldn't manage to do this because most of the photos that it got that contains glass, that contain wine, is not the photo of the glass full of wine, just half full or something like that. And it couldn't do this task because it couldn't imagine anything like that. There was no data, or next to no data, that was relevant to the user input. And once again, I emphasize that it is not an engineering problem. It is the structural problem that cannot be solved. It can be tweaked. Some problems that appear can be solved punctually, but not completely, because the machine doesn't know what it doesn't know. If some information was not given to it, it cannot use it to produce the other result. With this, I'm done with the basic overview part of the video and I start the analytical part. I now will analyze the general tendency, the trends of the LLMs that we see now. No doubt, LLMs are very powerful. They are broadly used. They can be used for in many different ways, for many different topics. They can do stuff, but it doesn't matter that there are no problems and no limitations. And you definitely know about the first problem, the problem of sustainability. I am talking not only about environmental sustainability, but also about general business and data sustainability. I will talk right now about 4 different parts. Firstly, it is data. Large language models have already parsed through all the data on the internet. It has already read all the books. It has already seen all the movies, all the YouTube videos, all the research papers. All this raw data is already used, and it is really hard to find more useful data than it is already used. The second part is water. Large language models use data centers. They are just named data centers, but they are pretty much a very big powerful supercomputers that use a lot of energy, a lot of power, and in order to work they have to be cooled down. They are cooled down with water. Of course the water is used and then it vaporizes, but that water that is used, it cannot be used for any other purposes. For example, it cannot be used for irrigation. Of course it will come down with rain. At what proportions, when, where, no one knows. It uses water that might be used for more productive ways. The third part is chips, microchips. In general, there are about 2 or 3 main suppliers of microchips. The first one is TSMC. It is about 80% of the world supply. On the second place is Samsung. I guess it is about 7 or 15, I can't really remember percent. And I think also there is Texas Instruments with 5 more percent. So 3 suppliers. But basically one main supplier for everyone. But the problem is that microchips are used everywhere right now, in the cars, in the cell phones, in different technology, and also in the processing units for computers, so also for data centers. And data centers need a lot, enormous amount of them, and it just physically can't be manufactured at the rate that they need it. That is why it is almost impossible for you to buy a cheap, commercially viable GPU to play computer games of the new generation. It is very expensive because of the supply and demand. And the last, fourth topic of sustainability that I want to talk about is electricity. You might have already heard that Google has bought a nuclear power plant at 3 Mile Island, if I'm not mistaken. And yes, because they need it. They need a nuclear power plant for to generate enough electricity at the constant rate for the data centers, because they always need it. If data center stops, everything stops. It is really hard to renew the process. Well, it is not hard, but it is very expensive. The second very large problem that large language models have is that they are not profitable for the companies that run them. On the contrary, the companies that run them are losing money constantly. If you read the spreadsheets of the revenues that those companies show you, you won't really see that. You will see the revenue streams of billions of dollars. But where do those revenue streams come from? They come from the investments of one big company into the other big company, from one AI company to the other, and then the second to the third to the first to the fourth. And with this net, with this interconnectivity, there is a visibility of high returns, but they are not real. Those are not real returns from the end customer that buys it. If you ask me, I don't really think that the revenue from the end customer is more than 0.1% of what the companies lose to run the big data centers. The next problem with large language models is that they are not consistent. I will divide this topic into 2 subtopics. So the first one is that yes, large language models do get better. They give better results. They optimize the computational powers better. They code better. But at what cost? In order to give better results without significantly advancing the algorithm, more computational powers are needed. Either or more time is needed to give better results. But still, more time means that the data center has to run longer to give the better result, which also needs more power. So to make the model smarter and faster, more computational powers are needed. So more data centers are built, they are advanced more, and we come to the problem of not sustainability. The second subtopic is that all large language models are both confident and convincing, for better but mostly for worse. Just imagine the situation that you have to dive into the topic that you are not expert in, or you don't really know anything about that. You rely solely on the AI to give you the right solution, and it will give you the answer in a very confident and convincing way. So without any expertise, you cannot tell if he is telling truth or he is telling something wrong. And that is a problem when we go higher and higher and higher on the complexity ladder of the questions. The next problem is very connected to the first problem that I have talked about. In order to grow, in order to give better results, AI models need more human input. At least those models that we use right now. And here's the problem. AI has already used most of the human input that is available online, which means that now they rely on the human input that interact with AI. But here's the problem. People interact with AI in a different way from creating something new and original. And furthermore, many people use AI now. Not only smart people that write books, that write the scientific papers. On the contrary, not many of those that use AI are smart, I'm sorry. And we already see that large language models become dumber after the widespread usage of AIs. And I speculate that it is because it is learning from the experience and knowledge of many people, democratic way. And here comes one of the more interesting rules of AI, which is called garbage in, garbage out. Which means that if you feed the model some trash data, it will give you trash output. And I speculate that it is exactly what we see now. In addition to that, there is already a lot of work generated by AI. So the data that is fed to AI is already AI built. And so AI gets incestual relations with data, which brings some very strange mutations, which lowers the quality of the output. Of course, this problem is already known. Of course, engineers try to solve it, but it is also an inherent problem. It cannot be solved because it is natural that if you use some genetic material, for example, over and over and over and over, some mutations that were previously latent come out and you find the Hamburg prints in the end. This analogy also works for large language models, for AI in general. This problem can be contained, it can be slowed down, but it cannot be inherently solved, no matter what some and or other people claim. Even mice that are being cloned, they cannot survive more than one day after some 50 or 54 clonations. And I think it is stupid to think that the machine that is built as an image of a human brain can be immune to such natural problems. And now we go further. AI and large language models are engineering projects. They are technology. Empirical data shows that technology follows some S-curve rule. At first, you can't really see the grandiose expansion of the technological capabilities. Those people that work with it, they see how it progresses, but the general public don't. After some threshold, the growth is exponential because the technology shows its capabilities, and the engineers that work on it understand it more, so they can provide the public with better experience, and public looks for more usage of it. After some time, the progression of technology slows down. The growth is still fast, but it is no more exponential. Furthermore, it slows down time after time, year after year, month after month. And then it achieves the fourth part of the progression, the plateau, after which all the further expansions, all the further capabilities require astronomically more resources than at the beginning, and people just cannot find the viable solutions to those problems. Not only we see such a progression everywhere with every technology, I can tell you that every time when new technology comes, everyone thinks that this time is different from the previous time, that this time exactly this technology is not going to follow the S-curves, and still it follows. Right now, many people speculate that AI will grow indefinitely and exponential. I think that they are wrong, those people that say it. I think that AI as technology is still a technology. It will follow the engineering S-curve because it is handmade. It is something that is expected. On this topic, I can remember one speculative paper from one of the leading people in this field. He claims that at this rate of expansion of capabilities of large language models, of generative AI, 2027 would be the turning point in which humanity decides if it will let AI grow indefinitely and uncontrollably, or more regulations to contain the growth and to understand AI more will be implemented. The key factor for the further predictions of this person is that in the mid to the third quarter of 2027, generative AI will already be much more capable than human and consistently good at that, which follows by two distinct scenarios. For now, let's leave them and follow this foothold that we have, the second or third quarter of 2027. If we see by that time that AI is really that good as that person predicted, then we have to think about the further AI revolution. But if, as I predict, then we have to move in a different way and in a different pace than we expected. With this, the analytical part of my video is over. And now I start the speculative part. I know it is hard to believe, but I'm a human too, and I also want to speculate to have a blik into the future too. So I will do exactly that. But beforehand, I have written some paragraph that is very to the topic of what I'm talking about now. We fantasize about some high-tech life in the future. We always do. But truth be told, the life is not that much different from 1930s, 100 years ago. It probably is not going to be too different in the future too. With that, I meant that we fantasize about the apocalypse all the time. We fantasize about the end of humanity in one or another way. We always predict things like that, and still it hasn't happened yet. It will happen, definitely. Nothing in this world is eternal, it is true, and still it is probably not this time. What we see now with the advancement of AI technology resembles closely what we have seen in 1999 with the tech bubble. I'm sorry, I wasn't born back then. I was born in 2002, but still I know some information about that, the general overview information. There was a old technology called internet that came to the public, and the public and businesses decided to try this know-how and to implement it in some way. People didn't really understand how to earn money on that, and so they implemented it into their business, waiting for the results, waiting for money to flow, but it didn't happen somehow. Investors invested in those technologies broadly, and they also expected returns, but those returns didn't really happen. They didn't really appear until I think 2010, such returns that they wanted. And so this bubble bursted. Of course, the situation now is different, but not critically different. Back in 2000, in 1999, people have seen that the companies have no returns, they have no revenue. The people that invested in that stuff, they bailed out, which caused the further effect of the burst of the bubble. People that work on AI now, they already know about what happened back there. They remember it very good, I'm pretty sure. And in order to stay afloat for longer, in order to buy themselves time to, for example, develop AGI, which I don't believe will be suitable in the way that we think about it right now, basically to win time, to win big. But I speculate that it will not happen, that the big giants that populate, I think it is 70% of the returns of S&P 500, I guess, approximately, they will burst, or at least they will shrink significantly as the result of the burst of AI bubble. But I'm not going to stop there. I don't think that it is all doom and gloom. On the contrary, I am very optimistic about the further tendencies. I speculate that the conditions that will happen will closely resemble the further conditions of early 2000s with the development of internet. People who really wanted to understand this stuff, they worked on it, they worked inside it, they worked with it, and somehow, with some time, the completely new dimension, completely new internet environment developed itself by the capabilities of millions of people that tried it, that worked with it. I am also pretty sure that the AI technology will have the similar tendencies, the similar way as internet did in the early 2000s after the burst of the bubble, AI bubble of course. I think that the base of AI work will be the smaller models that are expertised in some fields, in law for example, in translation, in anything. There are already great examples of smaller models that do a better jobs than large language models in some concrete fields. For example, NASA has used the artificial intelligence to find the planets with some definite properties. People before, they looked at the data by hand and they have found a lot of them, and still when AI was given the same task, it has found many times more planets than people did by hand. Why? Because AI was built on the idea of classification. They deal with it very good, they deal with it great. The other example is DeepL Translate. It is AI model that works only on translation, and it is great at it. It can translate from any of the pairs of, I guess, 80 or already 160 languages. It is mind-blowing, I would say, and the translations are on par with the professional human translations. Furthermore, I have used some other tool to translate PDF documents, and some other tool couldn't really put the translation into the document in the right way, in the beautiful way as it was before. But DeepL Translate did it without any cost, well, I did it without any cost because I used the 30-day free trial. But it would cost me some more if I decided to use it more. Well, I did not yet. And the result of the translated PDF document was very good. I didn't have to do anything with it to make it better. I couldn't make it better even if I wanted. Further example, cancer research with the newer AI models that specifically try to find cancer cells. They help doctors to identify cancer on the earliest stages and easier than doctors did it before. Furthermore, the drone warfare. In the war in Ukraine uses AI to identify the moving military vehicles on drones to hit them more precisely, to do it in future, hopefully, without human assistance. And those are just tiny parts of the progression that is already visible. We see that smaller models do better job at specific tasks than large language models. And I think that it will continue, it will go further, which means that resources and capabilities will be dispersed along more players on this new field. It will not stay only in the hands of the Magnificent Seven at the top of S&P 500. Many people, smaller players, will have their part, and they will take it, I assume, from the already bloated prices of the already bloated companies. But what about LLMs, you ask? And I think that there will be place for large language models in this environment, but not as a jack of all trades, but as a hub in which smaller models are used for specific tasks. And by the request of the user, large language model decide which smaller neural network will be used for the part of the task given. I think this will happen, and I think that the hub idea of LLM is something that is to be expected. With that, there are also concerns that AI will replace people. I don't think so. I think that AI will replace the existing system of working that we have. Yes, at some point it will be more viable to use the artificial intelligence to solve some of the given tasks by the business, and it is the disruption of the job market. But on the contrary, these models need their captains. captains. They need users that can intellectually give the right request to get the right answer. And they also need users that can identify if the model is generally wrong or the answer is incoherent. So without walking around, I think that the flow of the jobs will go away from some narrow experts and into the field of generalists that can see the bigger picture and identify the problems in different ways, in different categories. So yes, although some, and I think many or even most white-collar jobs will be replaced by AI, there will appear even more positions for those people that have to rule AI. And that is only one example that is on the nose what I see the tendencies might be. And there are way too many unknowns in the future than known stuff, so I can't really tell you what will definitely happen. But I have already told you what I think the general trends will be. With this forecasting and prediction part of the video is dealt with, and the only thing left is the recommendations. In general, you have to understand that AI is already here. It has already disrupted the market. It will only disrupt it even further. It has impact and it will impact the world even more. So if you want to be a Luddite, or if you just want to close your eyes on the things that happen in the world, it is not going to help you. It will only harm you. With this being said, the number one recommendation is not to rush. It is easy now to rush to the conclusions that AI will solve all your problems, so you do not have to do anything and just lie down and rest. Or that AI will kill all humans. Why? Because do not rush to the conclusions. As I have said in the second part of the video, let's just wait till the middle of 2027 and see how it progresses. See what the news around AI are and other stuff. You will have the feeling. Do not rush to the conclusions. Secondly, you should learn more about AI. You should learn about architecture, how one model is different from another, how the model that generates images is different from the model that translates text. There are many nuances that are interesting, and if you like this stuff, you should really check some of it out. Thirdly, and I think the most importantly, improve your brain, improve your general knowledge, improve your understanding of your surrounding. You have to understand that AI is information based. It is not based on reality, it is based only, their results are based solely on the data given. So if you understand more about this world, not just general facts, not the encyclopedial facts, because AI will, it will fuck you up with encyclopedial knowledge. No, you have to understand the better processes, the interconnectivity between different aspects of life. You will rule over AI and not the other way. You will be the bridge between data, which AI represents, and reality, which you represent. And so in this situation when AI gives some result that is inconsistent with reality, reality has to win and you have to enforce it. And lastly, tinker a bit about implementation of AI in your workflow. If you're a white-collar office worker, of course, You see, AI is an instrument. It has to make your work easier. Instruments do this, either easier or more productive. So if there are some manual database tasks, for example, that people do and do it very slowly and inconveniently and not effective, maybe it should be better to use AI to manage the database, to cluster the database into categories and to bring the new data to the already existing categories. AIs are good at it. They are built on the idea of this kind of work. And if you are an entrepreneur, you should think about how to build your new enterprise, your business around AI, with AI in mind, because it would be harder to supplement something already existing with AI, and it is much easier to build the overall architecture with AI in mind. So AI will do some defined job that would be worse if human would do. With this, I'm done talking. Thank you very much for your attention and thank you for being with me this whole time. I ask you to write in the comments what you think will happen in the future. Do you think that AI will replace your job and why? And if you think that I didn't touch some topic and that I should do this, please write it in the comments. I appreciate your engagement with this video and never forget to think further.